Hello, the contact how are things?
Good. Busy as always.
I was in India a little while ago, and the temperature over there was touching 38, and I came here and the temperature was -6. Oh, that was quite a shock. Quenching.
By shock, you mean a thermal shock.
Exactly. It was quite the rude shock. I think the winter in Canada, in Waterloo, has been kind of weird, in the sense that it is still dragging on. Next week also there is no reprieve, and it's coming to the end of April. So lots of people are beginning to feel that being locked up itch. So, but anyway, that's the.
It's about customary this time of the year, I think.
Yes.
And mid-April rolls around, in Canada, northern New England. There's still snow on the ground here. What can you do?
You cannot avoid it. You can only wish. So, but anyway, that's how things are. So, Dipankar, at least in Waterloo, and I think it is fair to say in many parts, right? Engineering education is facing some challenges, right? I think the impact of AI, the impact of changes in the market space, right? I think all of these things are in a way causing challenges in the education realm. So we need to think of some alternate ways in which we can rejuvenate the interest in engineering, right? Make it more interesting, make it more viable. A couple of years ago, we used to basically we were all talking about capstone projects being a very important part of engineering education. Every program, even ABET in its accreditation setup, right? They made capstone a very important part of the accreditation process. But today, if you look at the capstone project, the capstone will focus on design, it will focus on prototyping, it will focus on testing, but the analysis and analytics is missing, right? And the reason for that is there are various reasons, but in my thinking, the reason is that the time span of eight months or 2 semesters, right, is too short. So something has to give, and people just take out this analytics part, right? So I think it is time to refocus a little bit on the analysis part and make analysis a little central to the education process. So we have worked together now for over 9 years, and I think we have worked very well. I think I would like to basically adventure into a slightly different, a slightly a different way to sort of bring analysis back into this into focus, right? That kind of domain, and I'm going to let Andrew present his ideas, and then near the end, I will jump in to talk a little bit more about how I see this whole thing panning out. All right. So, right. So it's an exploratory meeting, right? I would like to explore and discover a bigger role for us in the Ideas Clinic with ANSYS, and at the same time, I would like you to please tell us a little bit about what role would be best suited for us. Okay, so keeping that in mind, I will let Andrew speak to whatever he has prepared.
Perfect. Thank you for that, St. Jeeve. I just want to say good afternoon again to Parker. Thank you for taking the time out of your busy day to meet with us. I just want to take a few moments before going into all those great ideas that Sanjeev mentioned. I just want to provide an update on some of the things that are really working well already and some of the ANSYS related curriculum development initiatives that you have become familiar with, but kind of how they've progressed over the winter term. I think it's been 4 months since we last met in December, so we've built
Yeah.
up a lot of exciting momentum since then. My main goal of kind of the discussion today is to continue the dialogue, first of all, that we have between the University of Waterloo and the Ideas Clinic and ANSYS, but kind of showcase some of the simulation-based curriculum development work that we've taken to the next step, in my opinion. Janos, Caitlin, and Gotham have actually played key roles in a lot of this and pushing this forward. They've been really pivotal over the past 4 months. Maybe share some feedback that we recently received regarding ANSYS as an academic tool. I'll talk about that in one of the slides. And then more importantly, I want to kind of explore those initiatives that Sanjeev alluded to that can kind of scale simulation-based learning beyond just mechanical and mechatronics level engineering, at least here at Waterloo and beyond, to reach other disciplines like nanotechnology, even physics, things like that. I think by sharing kind of these updates and proposing some ideas to you, I think we can hopefully strengthen the engagement that we have together. So I guess without further ado, I'll start on this slide here. So the next two slides, I think I just wanted to showcase some of the case studies that we've actually been developing. So this is hopefully some of the things that are really working well currently. Some of these are really new, but some of these you've actually seen already. But some of these are actually all of them are on the brink of being published on the ANSYS educational resource page or the Learning Hub. We've gone through the process of passing on all of the documentation. We've created lab manuals and documentation for each of these case studies. We've created high fidelity simulation models that are coupled with experimental data. And we've passed that on to Janos and the team at ANSYS for their input and their validation. And they've passed it back to us. And we've gone through a few kind of rigorous editing revision iterations now. And if they're not already on the Learning Hub, they should be within the next few days. There's 5 of them currently, but we have about 10 of them on the go right now. But before I dig into each of these, maybe taking a step back a little bit, when ANSYS first approached us to kind of help develop these educational resources, at least as long as I've been developed or a part of this, but probably the better part of a decade now, one of the key differentiators that I think Waterloo has brought or attempts to bring to the table is this what I like to call a hybrid instructional approach. So it's not the traditional hybrid methodology that we're all kind of force fed during COVID, where it's partially online and partially in person. The word hybrid in this sense means it's blending theoretical concepts with analytical models and a very simple, easy to execute hands-on experimental setup. And it's something that's affordable and scalable for student use in undergraduate as well as graduate environments. And then we kind of use these systems to calibrate a predictive ANSYS model or simulation that's high fidelity. And the key is maybe not high fidelity, but we tailor the level of fidelity for the audience and the student learning context. So if it's a first year class, it's a different expectation and a different framework or scaffolding than we give them in a fourth year tech elective versus a graduate level. So I'll give a good example here. This is something that's new, but one of the recent case studies we are working on is this. It's called a 3D printed cross flow heat exchanger. So the goal here was to make a conjugate heat transfer model, or let's say idea, tangible and intuitive to students. So we designed and printed a small handheld heat exchanger using standard FDM methods that everyone's familiar with. But the twist here is that we dope the filament with high conductivity copper particles. So in this case, we use copper, but we've tried bronze and we've tried a few other ones. There's a bunch of commercially available filaments to do this. But the reason we did this is to enhance the thermal conductivity, and it allows us to print these geometries in a scale that students can see and feel and kind of disassemble the device to get a visual understanding of the flow paths, the heat transfer inefficiencies, and things like that. And it kind of bridges the gap between the abstract theory of heat exchanger design and the real world design trade-offs that you have when doing something in a geometry constrained environment like that. But one of the key contributions of this particular case study is the fact that we used a material that is not popular, and we didn't know the exact thermal properties of the material, so it makes simulating it difficult. So we created a kind of a complementary, a very simple experiment where we printed these tetrahedrons and we put them on the 3D print bed as a hot plate or a heat plate. And then we just measured the transient thermal response with an infrared camera or even a point measurement using an infrared gun. And we then calibrated that to an ANSYS transient model by varying the thermal conductivity and the specific heat capacity. We were able to obtain those values empirically. And the students really like seeing this because we can effectively have a small module in this on how do you create a custom material. And this is an interesting way. A lot of the times custom materials are done in like biomed applications with soft tissues, but this is one where it's a thermal kind of exercise that I think is broadly applicable to a lot of students. So it kind of fully closes the loop for their experience when they start with theory and then they move through maybe the physical fabrication of 3D printing something and then testing it and finishing off with a simulation that's not only validated and calibrated, but it's a predictive model that can help them do either abusive or more exotic things. If you want to print it out of something or utilize a material that's too expensive or something that is odd or unobtainable, then you can still do it once you have a calibrated model. So it's kind of an approach that we like to think encourages design intuition, critical thinking, and the credibility of the simulation, I think, is the most important thing from the ANSYS partnership perspective, because it trains the students to utilize it as a tool that needs to be calibrated and validated, but they develop that trust early on so that we can capture them and allow them to grow into a fourth year design project where they're using it as an integral part of their design process. So that's one that I hold near and dear to our heart because I think it's pretty innovative. The charcoal barbecue is one that we're publishing soon, and that was a pretty cool multi-physics type simulation that we presented in the past. There's a few others here. We've done a Venturi tube where the students get a 3D printed Venturi tube and we hook up a vacuum cleaner to it. And then we measure all these different pressures and temperatures quite easily using these handheld tools to demonstrate Bernoulli principles. So there's a few undergraduate fluids profs that are using this currently, which is really exciting. And I kind of put beside these the state of each of these. So I have on beside this one experiment validated, simulation correlated, and documentation completed. So it's at the stage of publishing. All the T's have been crossed and all the I's have been dotted, and it's ready to go. The tuning fork one here is quite interesting because we give when the students have no knowledge, like within the first 2 weeks of their engineering undergraduate, they have no knowledge in stresses, strains, Fourier transforms, high level mathematics. They just understand maybe some form of vibration or they have some musical background. We give them all these little tuning fork sets, and effectively they're doing a natural frequency analysis and discovery at different tuning fork lengths, and they have to find out the material. So they have to say, okay, well, we're not telling you what this material is. Can you use a exploratory approach to figure out based on this experimental frequency that you're all measuring or this tone that you're getting um, what that is. Can you still hear me? For some reason, the video dropped out.
We need examples like this to showcase appropriate use of simulation tools within curriculum. So these are perfectly positioned for that.
Okay. Sorry about that. For some reason, the network lagged a little bit. Can you still see the presentation?
I think you were speaking too fast.
Ah, okay. There's lots of great ideas here, Sanjeev. That's why.
Sorry, I didn't mean to. Go on, carry on.
No problem. Maybe I'll see. I don't know. It's complaining about my camera for some reason. But anyways, so these two in particular are very interesting. We've done one on the a walking crutch, which is kind of like a way, an assistive way of utilizing crutches that aren't underneath your arm, so you still maintain the mobility of your hands. And this was when you have a lower body injury. This was done in conjunction with some biomedical engineering students, and modeling not only the deformation behavior in this situation, but optimizing the pedestal of the foot for a stable and slip-free contact path. So this is a very simple and relatable way to introduce students to a contact problem, which I thought was really ingenious. The Venturi tube and the tuning fork are actually case studies that we have submitted a paper, both Janos, myself, and Caitlin, as well as Chris Rennick at the Ideas Clinic, have submitted a paper to SIA, which is the Canadian equivalent of the ASEE. And there's a conference that's actually co-located in Montreal this year. And here's the paper. It's at the stages of being published, but the title of the paper, let me see if I can zoom. It's Optimizing Engineering Education with Simulation, Teaching Core Concepts Through Integrated Case Studies and ANSYS Analysis. So pretty innovative tool, in my opinion, to demonstrate this hybrid approach where we're coupling the analytical solution with a simulation as well as some experimental data. I think the experimental data is the key differentiator that we're using, because looking through the wealth of information that's already on the Learning Hub, as well as the educational resources that ANSYS has, a lot of them don't have any trust being formed with, let's say, the user, in terms of here's an experimental validated data point, or here is a contour plot of the temperature or the stress or whatever that we've obtained experimentally. So hopefully that makes some sense. So I'm looking forward to presenting that. I think it's in June this year. We did have, sure.
Well, before I forget, so will you be in Montreal in June 22nd at the ACE conference then?
So my plan is to attend both. I haven't registered for ASE right now because I think as a Canadian we need to maintain a membership that I actually am not a member right now of. But I can stay. If for us it's easy. It's like a 6 hour drive from Waterloo. And I think Caitlin and Caitlin for sure I think is attending that. Maybe Janos as well.
Yeah, yeah. The reason I asked is very selfish is I'm going to be there.
Okay.
I have a panel discussion or something I've been invited to participate in. So just as a FYI, it'd be a real bonus if you're there, of course, but that doesn't mean I'm trying to twist your arm into where's the SIA conference?
It's co-located in Montreal as well. So that's the
Oh,
benefit.
really?
A lot of it's not at the same faculty, but it's the same institution. I think they're just sharing resources, but the benefit is a lot of the locals that, let's say, in the Canadian engineering education realm that might not be able to go to the States, now it's coming here. So it'll be a lot more well attended by Canadian institutions, in my opinion.
Okay. Okay. All right. All right. Just curious. But do let me know in case you're going to be there, Andrew, and we'll definitely find time together.
Okay. The next slide is actually quite interesting. Last month in March, Catriona and Gilles came for a visit here. I think those are their current titles, but they stayed for the entire day and they did a nice presentation to some grad students, and myself, as well as another 5 or 6 professors that actively utilize ANSYS products. Many of them were LS Dyna users, but there was a few others that were using other suite of ANSYS software, CFX and Fluent, stuff like that. But we all met and kind of had a group think regarding the best way to move forward with licensing, because I know the license servers that the LS Dyna folk use it's become increasingly difficult for them to maintain. So Gilles and Catriona gave a nice presentation, and I actually followed up with the Dean of Engineering at Waterloo a couple weeks after this meeting, because they exposed something quite interesting regarding the amount of money that we're currently paying for all the licenses individually is more than a campus-wide license would be. So I'm pushing the dean in that direction, and I think we're gaining traction, and it's going to happen quite shortly. For budgetary reasons, they like anything right now that can save us money, and effectively we'll get all the research, productivity, and licensing that we need, with the benefit of not having to use the student version for our undergraduate students. So I think that's pretty interesting. I've taken 2 slides out of what we presented at this meeting to Catriona and Gilles here regarding some challenges and some needs. Mainly, it was regarding certainty on license renewal and stuff like that, which Gilles really did a good job of saying, if you need to expand your license pool temporarily, it's very easy to adapt that. So that was really well received by the university. Kind of a tangent discussion from this talk. I just wanted to bring you in on the loop there.
Oh yeah, no, I was actually supposed to come on that trip with Katrina and Shiva, but unfortunately, I had to be in another place. I couldn't come for the meeting, but they've kept me posted because they know I have a very active interest in the health of our relationship. So they updated me. But thank you, Andrew. This actually is good to hear it from your side rather than from theirs. So yeah.
Okay, great. So now that I've kind of told you about what's working well at the university, I want to expand and kind of give you some information on some of the ideas that Sanjeev alluded to. So, in my humble opinion, the Masters of Engineering program at the University of Waterloo, and this is something that I've seen attending conferences elsewhere. Any North American university is interested in something like this, but they're underserved in the current economic climate in my opinion, which is one of the reasons, at least at Waterloo, they have somewhat decreasing enrollment. So to enhance and modernize our offerings for these students can really help to improve this, in my opinion. So kind of a more holistic approach towards.
Can I do this slide, please, if you don't mind?
Absolutely, Sanjeev. Go ahead.
Sorry. Dipankar, the key thing is that there have been a lot of ways in which universities have tried to sort of expand classroom-based teaching. So, MH program was definitely one of them. It was seen as a method of expanding the undergraduate education without the heavy weight of research funding. So MH was kind of developed for that purpose, and it was touted as a lot of potential. But I think the earnest part of the whole thing is that it is mediocre success, and as international students wane, this program is taxed even further, right? So I think there is a role for MH to play, but I don't think the universities found the right nail to hit. They've just been kind of banging away in a random direction with a hope that something will hit. Now, there's one program in Waterloo which is very successful. That program is successful because it is sponsored by a company. So Ontario Power Generation is a very large hydro provider in our province, and they sponsor this program on transmission lines and side of things. So that MH program has been very, very successful. In another institute, they basically had a program with the Air Force. Again, that program was very successful because the pathway to success was paved with a collaboration with somebody outside of the university, right? So looking at analytics, I think what I wanted to do was I wanted to explore the potential of offering a two things: a certification and a MH, a master's degree.
Right.
It's in an online version. So let me explain what the certification, how the certification and the master's program would work. There are a lot of students I met in India who would be interested in getting a certification for doing basically a for in say the use of some analysis software such as yours, right? They would like this. They would like this, a university to stamp it, say, "Oh, University of Waterloo gave me the certificate," etc., etc. Now, the University of Waterloo, although we are not in the business of certificates, we would like to channel all the potential undergraduates to do a graduate school or graduate studies in Waterloo. So we could basically say, hey, if you have two certificates, we might give you one course equivalence in our MH program or something like that, right? And these are numbers that I'm just coming up from the top of my head. So the bottom line is that we would like to create a certification had a MEnt program tailored and focused only on the analysis side of things. I would want majority of this to be online, and I would like to use modern tools from the AI uh, library to basically support and sponsor this. So basically, if somebody is um, doing the certification, say in an area which is sort of opposite time zone to us, right? They will get 24/7 help, and basically the help will come from an AI-based tool, but it will be authenticated by a person next day in case there is an issue. The issue will be addressed. So I would like to take our partnership and move it towards building this certification and a master's program in analysis. And the exact domain we can figure out. There are lots of other people who will need to be brought into the scope. At this point, we are only searching for we're only brainstorming and seeing if there is even some some understanding. Yeah, this is exactly what we can do together. Then we can proceed from there. So with that, I will basically let you jump in, pipe in, and tell me your perspective, and then we can proceed on with the discussion.
Yeah, absolutely. So in terms of enrollment, as Sanjeev, sorry, that wasn't my question. So you talked about that example of the possibility of, or rather, what you ran into with these Indian students who were really quite interested. Yeah. So, but they'd have to enroll in this program, and they could be remote and offsite, or is there some on-campus requirement here as you're envisaging it?
I am envisaging it as online, but we could definitely have a in-person portion. So if the numbers are large, we can do the in-person portion in their vicinity, in a college nearby, or if there is enough interest, we can do it on campus here. If we do an MEng, right, there could definitely be a part which is done here. So MEng is typically 8 courses or 9 courses. So maybe 1 course or 2 course equivalent could be done in person. The rest can still be done online.
Right. The second part of it that came to mind is the economic sustainability part of it. Are you thinking that it should mostly self-funded from the tuition or the enrollment fees that are charged for the certificate, not the certificate, the engineering program, of which part of it is the certificate?
I'm hoping that the system will make some money for sure, right? Otherwise, it is not possible in the university systems to do something. But I think it may need some startup pump in the beginning just to get started, which could be recovered. But I think that part will have to be done. And we will have to do it together as a partner. I don't think the university could do it on its own. But together, I am sure we could do something reasonably well.
Okay. I think Andrew has probably more to say about the proposed content and all that. So let me hold my questions until you're finished, and then we can just.
Sure. We can circle back to that in 5 minutes or so. I'll try and do this quickly. But regarding the proposed content, 2 things before I go through all the proposed streams of what we were saying. I think the only existing program like this currently is there's nothing in North American institutions. The University of Madrid has done something similar to this, but it hasn't been to this scale. The other thing that's a unique opportunity in Canada, and I think it applies to the United States as well, to maintain a professional engineering certification, you need a certain amount of hours of what are called like complementary professional development hours. And they have to be technical. There has to be a certain amount of those that are technically relevant to your area of expertise in engineering and the domain that you're practicing in. This could supplement some of that, or some of the revenue stream could be something that suffices for those hours, and employers could potentially pay for it as well, which I thought was an interesting avenue. But as far as the streams go, The traditional ones, the structural analysis, fluid dynamics are there obviously, and those are kind of the cornerstones of everything we've developed currently. And I'll show you a menu of all of that, which is overwhelming in a second. Electromagnetics and radio frequency is another stream, or robotics control and automation is another stream. Digital twin and simulation driven design is another one that I personally find very relevant. Multi-physics simulations, additive manufacturing. There's huge resources on campus with many multinational labs and collaborations regarding additive manufacturing, life cycle analysis, and the list can grow. But you might ask yourself, well, that sounds like a large menu of content to develop, but we've done most of it already. I've taught a course that's specifically catered to 3 of these. In the past, it was a graduate course to about 50 students, so we can scale it up or down based on enrollment from that. We've also done these workshops that ANSYS actually shared one of my LinkedIn posts regarding this, and it gained a lot of traction. And because of that, I've had people reaching out regarding how do they attend these workshops remotely. But right now, we're currently only offering them in person. There's about 200 to 300 undergraduate and grad students that attend these workshops that are specifically catered towards simulation-driven design, and it's teaching them the ANSYS tool set, and it's only discovery. Really, there's an advanced one that bridges off into mechanical and fluent, but it's mainly discovery. All the case studies that we talked about, as well as some industrial collaborations that we've done. So an industrial partner might approach us saying, here's a problem that we have with a product or a system or some sort of process. Can you simulate it to help us understand it better and potentially optimize it? Fourth year design projects, as well as involvement in student teams. I'm the faculty advisor on a student team here. That's the biggest one on campus, and they actually have tons of problems that they simulate on a daily basis. But to dive into the menu, I don't want to go at any of this in a lot of detail, but I'll explain the color coding here. Each of those streams I've broken into a slide here, and I've given you color coding on how ready would we be to immediately roll this out today, next week, next month. If it's green, it effectively means all the resources are there in terms of a simulation model and experimental setup and a case study or lab manual to pretty much go and immediately teach this. So that's something, anything that's green here, I could teach tomorrow. So a few of these are things like cantilever bracket, a spring under uniaxial load, a bicycle crank, topology optimization of that bicycle crank, some nonlinear examples on a chair, that IKEA chair that I think we spoke about in the past, the walking crutch. I have a really cool example with a plastic key that goes into a key hole or a tumbler, and the key deforms as it goes against the lock of the key. Some dynamic and impact analysis that we already have done. So this is the structural analysis. This is some of the content we've developed already. As far as the fluid mechanics goes, we've done a lot on this, but some of the color coding for the yellow one means that there's some, let's say, development still outstanding. We could probably within a month be ready to roll that type of thing out. And the red one, I would say, would take an entire term. So we've been approached to do blood flow in a coronary artery for a stint and do a case study regarding that. So here are some ideas for aerodynamics and external flow, internal flow, and heating, ventilation, and cooling. These are all really big, let's say, outcomes for students in the programs that we have here in Waterloo of where they would end up and kind of be in the workforce. And then some multi-phase and thermal fluids. So boiling in a heat pipe, the barbecue grill that we've already done, and even a rocket engine combustion chamber flow. So few really cool, relatable, let's say, examples that the students have shown. And this overlays some of the existing content that we've already developed regarding these. For the electromagnetics and radio frequency, I've subdivided it into antennas and wireless communication, and then power electronics and electromagnetic compatibility. Some of the cool ones, in my opinion, are this evolved antenna optimization, where it's using genetic algorithms and a machine learning model to dynamically do a topology optimization on this antenna in the radio frequency domain. Kind of like a topology optimization, but using this evolutionary algorithm. So that's something that we've actually published on quite recently. Wireless charging coil optimization. This is something that all the students have exposure to, and it's kind of a more modern example of something that they've experienced in their everyday life. Even regarding EVs and electric motor cooling, we've have some examples regarding that we're currently in the development stages of. I wouldn't say these are ready to roll out yet, but they're close. For robotics control and automation, we actually had a spring mass damper setup that had an actuator with an active an active dampening element that we could change using a MATLAB Simulink model. We could simulate that as well. So instead of using analytical formulas to simulate the behavior, we could do it using finite element, and that would be something I think the students would really like. Path planning for a robotic arm and kind of measuring the dynamic or modeling the dynamic behavior of that. We've done a lot on autonomous systems and AI integration. So regarding, let's say, localization and path planning for robotic devices, we have an amazing lab on campus that we can do a lot of experiential content regarding that. So that's the robotics automation and control kind of pathway for the students. This would be in conjunction with that lab on campus called RoboHub. The digital twin and simulation driven design pathway has two individual sub kind of themes of AI and machine learning and simulation, and then optimization and material selection. I think this one here I presented kind of discreetly about at the NAMES conference in Ann Arbor last year. There's a ton of stuff regarding that. I think we could turn that into its entire own program, but I have it as kind of a sub pathway here. But we can cater this menu to suit whatever, let's say, appetite there is at that institution or whatever ANSYS kind of has from a corporate agenda. The final, I think there's two more here, multi-physics, so fluid structure interaction, acoustics and vibration analysis, and then thermal-electric coupling. The cool one, in my opinion, is the thermal-electric coupling regarding a generator of a thermal-electric generator and finding the efficiency of that. So it could be like a Peltier cooling or heating element. That would be something that I would really like to kind of showcase. But we've done a heat sink optimization for CPU cooling. There's a number of different things that we already have developed for this. And the final one here, I don't want to go into too deep on any of this. We can look at it in any detail if you want at the end. But additive manufacturing and lifecycle analysis, we actually partnered with GM, General Motors, to do a additive manufactured transmission yoke. And it was a topology optimization with a different objective. Instead of optimizing it for the strength or the displacement of the actual criteria that you're utilizing, we wanted to recover, this was an additively manufactured FDM part. We wanted to recover as much of the powder as possible in the process to improve the recyclability and the sustainability of the process. When you print lattice structures that capture powder, that powder is effectively wasted and it doesn't fuse to the surrounding material. So printing lattices that are specifically catered to allow the material to release when you shake it to recover the powder was something we spent a ton of time doing this, and it was really cool. Even modeling, I know Janos is a huge resource on this, and he had some good ideas that we're kind of ready to implement and move forward with regarding process modeling of the additive process itself and residual stresses and strains that might develop from the thermal gradients that are there. And then the final theme is life cycle analysis and sustainability. So how can we simulate the end of life recyclability assessment of a system or a product or an assembly, something like that, or even the post-processing of a part to allow it to decompose or disassemble or be recycled into something. So these are some of the ones that I think there's huge demand at the University of Waterloo, but I don't think that that's the only institution. I think this is the direction that a lot of institutions are going. So I guess with that, I'm going to just summarize really quickly with some of the things that I talked about and maybe some next steps that Sanjeev touched on in the beginning. But I think the strategic value that ANSYS, the partnership we have with ANSYS is already in place. We've built a strong foundation with these case studies, the curriculum integrations that I've talked about, the faculty engagement. I mean, I'm only one person with the Ideas Clinic, but I think the outreach to the rest of the faculty is huge, and they're all really excited about this stuff. But even some national and international recognition through the conferences that we've attended, and then this planned simulation kind of based graduate diploma, degree, MEng certification, whatever you want to call it. I think that the value there is already in place. But the budget constraints that Sanjeev mentioned are real. So any kind of proposals that we bring forward that aren't a cost reduction strategy to the department or the faculty often faces some significant barriers at the Senate level to get approval. So this kind of limits our ability to implement this at a large scale. So the partnership opportunity is kind of what our ask is in this meeting, and we see this as kind of a pivotal moment to extend the partnership that we have with ANSYS so we can kind of accelerate the development and make this impact as large as possible. So I guess with that, I'll let Sanjeev add any additional notes that he wants, but I'm happy to discuss anything that I flew through there at the end in more detail if you wish.
So Dipankar, I think it is we have the capacity to offer an image or a certification or an equivalent. That is for sure. But I think what I want to do is I want to as you can see the scope is quite large. I want to basically come up with a template which benefits both ANSYS as well as Waterloo as we go forward. Image would definitely be an attractive proposition for the faculty. I'm sure we can sell it. Certification also would be a very attractive proposition, along with a AI teaching assistant in each of those elements that can provide 24/7 certification. The monetary side of things we'll have to work together to sort them out, but I think they're doable. It is not they're not on the exorbitant side. It is just a question of figuring out, hey, this is how we want to do it. This is the first trial, etc., etc. And I think the third part is we are quite happy to train other university professors to um, uh, uh, as summer school or whatever, so that they can take some of these workshops and use it for education either at the undergraduate level or at the postgraduate level at their institutions. So we are open for that, but I think what we would like to do is take our relationship to the next stage and do some collaborative course development or program development going forward. We're not going to shove any project in front. No, that's not the idea. Whatever we do, I would like to do it together. And that I think is the essence with which we want to move forward.
Timing, any thoughts, Andrew and Sanjeev, about when you're trying to move us out?
I think this fall would be a little tight, right? But having said that, what I would like to do is preparation will take some time. Finding the first thing we will do is we will do some pilots, which might only have 30, 40 students, or they might be undergraduate, they may be fake students, so to say, right? But just to try it out, if we want to go global, right? We don't want errors to be coming up at that particular time. So we'll do a couple of pilots, and so I think starting the adventure in fall may be a okay thing. Launching the first set of students sometimes next year might be a okay thing as well. It will give us time to get it through Senate and through various other sources internally at the university as well. So that is roughly the kind of timeline I'm thinking.
Yeah. So, I think first of all, I do have to hop over to another meeting. So this is an important sort of topic, and I don't want to cut it short. Would you be willing, just from my own consumption, of course, yes, and possibly with Susan Coleman and one or two other people on my team, would it be okay for me to use these slides internally when I'm making my own pitch, basically? Would that be all right? Just for my team.
I'm absolutely okay with it.
Okay. So that was one ask. Second piece is that I can easily see. Yeah, sometimes I have to eat my words at ANSYS. But so far we've been tapping into the time of a couple of people like Janusz and I think possibly a few others. But given the scope of this, I think what I can imagine doing is getting dedicated time from a number of others on the team with kind of rounded out skills, for example, on the fluid mechanics side, on the electronics, electronic schooling side. So anyway, so we can certainly, because those resources are kind of under my direct control, right? So I can absolutely get the further kind of skin in the game, so to speak, from the answer side in terms of effort. And I don't know if you've had, I know Katrina and Gilles were there, but what's behind all of this is we have a new general manager in ANSYS Canada. His name is Rafiq Somani. I don't know if you've met him yet. The name ring a bell? Not really. Okay. So Rafiq is based in Toronto, and uh, basically the sales and technical support operations of I think his region extends to a few, maybe the Pacific Northwest. I'm not exactly sure. Nevertheless, so he controls the technical services and sales. Now, when we say sales, that includes the technical part of sales. Basically, almost sometimes indistinguishable from the technical support teams at ANSYS.
Yes.
And he came from leading our India operations.
Okay.
The last 3 or 4 years, which are there. And then we had luckily, a very tightly integrated commercial and academic efforts. By this I mean, you know, dare I say, it's pretty well understood that you really rely on a healthy, vibrant, organic relationship with academia to be successful on the commercial side. Sometimes in the United States, you have to remind people about that. So that's innately understood in India, and I think it's innately understood in Canada. Yeah. So where I was going with that is Rafi and I had several conversations. In fact, this trip that Gilles and Katrina made, and I was supposed to be originally on that, was going to be a bit of a campus hopping trip. So UT, Waterloo, McMaster, there were 1 or 2 other universities they were supposed, and because of me, they couldn't do it. So it's going to happen. The whole idea was to raise our engagement and level of commitment from ANSYS' side, right? So all of these words equals that I can very much imagine into skilled engineer time from other groups at ANSYS as well. Yep. To get all the help that we need to roll out this program, right? From ANSYS' side, essentially resources, teaching, mentorship, participating as contributors in project oversight and contribution. You know how it goes on and on, right? So we can, I can easily imagine getting 5, 6 more people onto this overall, right? The other part, where I'm coming to is getting hold of actual cash, right? That especially with this impending Synopsys acquisition, which will close hopefully in the June-July timeframe. And Sanjeev, and I know you're aware of this, right? Yep. That ANSYS is in the process of being acquired by Synopsys. So, yeah, I mean, it's looking good. And I think Synopsys as a company, I'm getting a lot of respect for, because I think we don't have to convince them about the value of a vibrant, well-funded academic program. Yeah. I don't see that, but still, there's kind of uncertainty in the air. And funding is a little bit frozen for right now in terms of discretionary funding, because people want to be very conservative as we go into Synopsys, so we are not essentially messing with the numbers that have been promised in terms of top line and bottom line. So what I'm saying is that it's not a lot of time. We're looking at 2 to 3 months at most, right? So tapping into internal funding is a bit of a challenge right now, because we budget year after year after year, right? So 2026 gets budgeted in September, October this year. Yes. So if you're envisaging something for the 26 timeframe, I can imagine us doing a lot of prep work to make the pitch internally, and then allocating funding, direct funding, right? Pankaj, I think as far as, let us just focus on the intention. If we are looking in the same direction, let's proceed to the next stage. Some of these money issues, right, they will solve as the picture becomes clearer on your side and on our side, right? I think
it would be nice to have money upfront, and that's wonderful. Like, it definitely makes the mayor go, but that's not the point. I think if we want to do something, let's do it with a proper need,
Yeah.
with a proper
But
goal.
I understand.
Yeah.
What's in your mouth? But the kind of approach we use to, for example, startup discovery, like 3 or 4 years back, through the program that we're currently in, is probably not a bad model, where, answers contribute something, maybe that allows, you know, fund matching, easier fund matching to come from other sources and so on. So if we like to get hold of some seed funding on top of the in-kind contributions.
Yeah.
So one idea I had was when I was listening to you, Andrew, I think we can make a pitch for the next round. You know how we have this funded curriculum program? You're aware of that, right?
Yep. Yep.
Yeah. So I was looking at the proposal submission deadline for that. Unfortunately, the last call kind of finished up earlier this year. But the next call for proposals is the deadline is September 26th of this year, right? And that allows us to go tap into some funding that's already there for so-called funded curriculum proposals. Now, typically that funding varies between, is it a proposal for a single course versus a series of courses, right? So in this case, we're talking about an entire program, right? I think we can very easily make a pitch for that while we're pursuing other possibilities. I would kind of encourage us to do that, right? What do you think? What are your first reactions?
Oh, I think it's a good avenue. Like I said, I think the only way to succeed is to do as much as possible and access as much funding from multiple sources as possible. But at least that'll gain some exposure, I think, on your end. So it's a step for sure.
Yeah. What you laid out in the slides, you basically have the content that's needed for a proposal. Especially when these proposals are very light, they're like a page or two, right? That's all they are. But all we have to do is enter the slides and put it into that form, right? So I'll pursue that. And Susan and I can help in that process. That will help going over the next few months while we explore other possibilities. At the very least, I think we can go about, if we can put a little bit more flesh around the bones about which are the areas where answers help, proactive in terms of implementation is most impactful in the short term. If you can sort of tap those areas, which I'm pretty sure you already have in your head, then I can go about the process of actually garnering those resources internally assigned to this project.
Okay.
I think yeah, that will be very, very good, because I think it will help us round off some of the things that we have talked about here in the proposal and convert it into a program.
Yeah. What it means that if we state it out, for example, and Sanjesh, that we say that, look, in fall of 2025, we'd like to start a pilot with one or two courses or whatever it is. I'm completely made up that number. Whatever makes sense to you. And then it ramps up into a phase two, in which we have gone through the formal process within UW for the curriculum committee and all the steps that you have to take internally. Meanwhile, it allows time for access to go beat the bushes and find out what more we can do beyond the sort of startup phase.
Yes.
And say, just I'm making things up again, by summer of 2026 or whatever the right time frame is, then we formally initiate the first cohort of the program in streams A, B, C, and D, or something like that. So if you kind of lay it out in a programmatic fashion, I think it'll be pretty clear to any reviewers or people who are going and asking for support and help and funding that this is a very structured strategic, multi-year kind of approach that Ansys and Waterloo is getting into a relationship with, right? And so something along those lines. That's my gut feel. I mean, think about it some more.
Yeah.
But,
Pankaj, if you're okay with the suggestion, right, that if this is worthy of pursuing further, right, maybe we should just meet on a regular basis to keep the so that we are looking in the same direction as we move forward.
yeah, the thing that I'm going to ask for is, you know what it is.
I know.
But they've got more broad-based support within Ansys.
Yes.
And
So
there are,
you can think about it. And once you get back to us, I just wanted you to keep this in mind. It may not be a bad idea to meet on a regular basis just for a brief amount of time, just to keep pushing forward.
Let's do this. So, if you don't mind sharing the slides with me today, I'm actually going on a trip tomorrow. I'm back Friday. So, in the meantime, I'll spark a few communications to lay the seed, and we can meet even as early as next week. Let's say roughly a week or a day or two today.
That sounds like a plan, just to sort of keep the ball rolling, so to say. And I think Andrew, if you will fix up that meeting, that would be just wonderful.
Sounds good.
And slowly we will start adding a couple of people to it. So as we add people, right, we will need to grow the crowd a little bit. It'll happen. It'll slow things down, but that's the nature of the beast. We just have to make sure.
I think that I have to, Sanjeev, because you know,
yeah,
my the way I support is I go around with my income and you know, to people who actually have budgets and resources. You know, I control those things for my immediate team, which is one small part of the program, right?
Yes.
So I need your help for sure.
Yeah, I need your help too. So don't worry. I think we'll mutually help each other, and I think that's the way we can sort things out. And I think Andrew would manage something when we start quite well. So I'm quite happy to put my support behind him.
Okay. Is there a chance I could hold on to you for just a couple more minutes?
Absolutely.
See you guys.
I'll come ask you a question in 10 minutes, Sanjeev.
All right.
I'll be over. Thank you.
So, two completely different things very quickly.
Sure.
One is that will you let me know if actually coming for the two co-located conferences in Montreal, the
Sure.
ACE, you know fairly shortly.
I should know probably next week.
Okay, take me over. I'm sort of having and flying myself. I'm actually registered because you know, the Access has a bulk registration for that conference. So I asked them to put me on because I had a panel discussion there. But if you're there, that'd be a good opportunity.
Sure.
It's just a 3.5 hour drive for me.
Oh, wow.
Montreal. Because I'm just south of the border, you know, so it's very easy for me to come to Montreal. And we have an office there, so I come there from time to time. Okay. The second thing is, would you consider the paper that you submitted there? Was it the tuning fork case study?
It was a combination of the tuning fork and the Venturi tube.
Yeah. We're thinking of expanding the North American meeting in August. This is the meeting that you attended last year.
Yep.
Yeah, the NAMES conference, into more simulation plus materials. Right?
Sure.
And this year it's in August in Atlanta.
Yep.
Would you consider coming to that conference and or submitting an abstract, at least just take it's almost cutting and pasting the abstract that you used here for that conference? I'm not committing to it right away because I'm sure you'll have to think about it, but Is that something you'd consider, this year's NAMES conference?
I definitely consider it in terms of conference attendance. We only have so much funding as faculty to attend stuff that's curriculum related. If it's research related, that's something different. I can dip into a different budget, but yeah, I can definitely think about it. The names conference last year was easier because I drove there, but
Right.
this one, it was fruitful. I really enjoyed the conference. It was good, so I don't mind attending. Let me
Good.
get back to you with a more firm answer though.
Okay. 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 The last topic, I hope this is not too sensitive, but I was asked to write an appraisal for the UBC
Yep.
application. Yeah,
Yep.
and I've done that. So the deadline was last week, and I sent it out. I just wanted to know
Okay.
that I did. Yeah. But on a private basis, if you'd keep me posted about the progress that's made on that front, I would appreciate it offline. Yeah.
I appreciate that too, and I did go there for an interview. Truth be told, I met one of the professors at Names last year, and he
Okay.
mentioned the position in December, and I applied with the intention of not really going because I enjoy Waterloo here, and he said you should still apply and just come just to see our facility and everything. And it was pretty. It's an amazing institution, and they were very interested in all of this. So I didn't really uncover everything. I left it very enigmatic, but they were extremely interested in a lot of
Right.
this. So it was a materials engineering position in that
That's
department.
yeah.
So
Yeah.
very relevant.
Yeah. Professor Mia,
Yep.
if I'm pronouncing his
Yep.
last name correctly, he's the one who contacted me, and I wrote quite a long, um, essentially reference letter. But um, but if let me know if that opportunity, warms up to its final culmination and it's something you're really interested in,
Okay.
because then we can push a little bit harder from our side.
Okay.
By this I mean actively. It's one thing to write a reference letter,
Yeah. Yeah.
right?
Absolutely.
It's another thing to actually talk to people and let them know how strongly we feel about a certain candidate.
Okay.
So if you feel that's appropriate, number one, but number two, if it's something that you would like to be done, then I'm there for you.
Okay. I appreciate that. That's very nice of you to offer that. So thank you.
Okay, okay, all right. But at the moment, you're a little bit on the fence, right? I mean, sort of a question of balancing what the opportunity might be versus what you're doing at UW.
Exactly, and frankly, this aligns very much with my pedagogical goals and the program that we pitched to you. I'd like to find a home for it, given the economic climate in Ontario, especially in the funding streams that are available.
Yeah, yeah,
Without additional support externally, I think it'd be difficult to maintain this because the university here is at least trying to get, and this is like off the record, but they're trying to get all the faculty to teach more undergrad courses, and I'd have less time to do stuff like this. Where at
right.
UBC, it's a different climate there. It's still
Yeah,
it's the way it was maybe 3 4 years ago. So they're and that department in particular was very interested in this. So I don't know. It's a shame that the governments may have mismanaged things a little bit here, but
yeah,
that's
yeah.
what it is.
Okay, okay. So let me know once the process goes further. And you did go out there, but you met other faculty and got to see with your own eyes the scope of the program. Yeah, yeah.
I was also selling them on going to names as well. A few of them go every year and they've been lifelong attendees, but many of them found this interesting and they were like, okay, I really want to see it. I'm going to go to Montreal this year. So, or sorry, Atlanta this year.
Yeah. Okay, okay, okay. Thank you, Andrew. And you can contact me for anything on this because I'm really don't do this too often, but I really feel very strongly about your mission, your goals, what you've achieved, and all of that.
I appreciate
Okay,
that.
okay. Thank you, Andrew.
Thank you very
And
much.
you should be a copy of the slides soon, right?
I'll do it within the next 2 minutes.
Okay, thank you so much.
Thank you.
Yeah, thank you. Yeah, bye.
Bye bye.